Thank everybody today from AFP for allowing BCE Network Consultants to evaluate your systems. BCE has been in business for over 15 years and is currently traded on the New York Stock Exchange. All BCE admins are professionally trained by Centric. They each carry at least one certification. Although all of our admin have been cross-trained, they have an area of expertise. This puts BCE above all of the rest. After several weeks of evaluating your systems, there are several suggestions that we have. So without further ado, we would like to get started with these recommendations, and I would like to introduce our first specialist, Aaron Chapman.
Thank you, Cheryl. Now, before I get started, I would like to impart unto you exactly how we have set up the network in itself. As you can see, we have started with two parent domains represented at the top of our chart. Each of these domains then has two child domains below it, designated by East and West. For the naming convention for these different domains, we chose to shorten the name from USA and Europe to USA and EU, thus shortening the fully qualified domain name of each computer or server in the network. Now, in each of these networks, we have a two-way trust for the entire forest going between each of them, so that way they can have connectivity and can talk to each other. We also have currently 4 servers in each domain, set up as server 1, server 2, and etc. We have designated at least 20 slots in our DHCP scheme, which will be talked about later, for future growth in the company. To keep things simple, we have ordered each of the servers, as I told you before, from 1 to 20. We have also organized it so that server 1 is always going to be our remote routing server and VPN server in each of the domains. And server 2 is going to be our main domain controller. We also decided to go with a secondary domain controller, which will be server 3. The primary domain controller will have all of the functionality of our major applications set up so that it has all of the primary functionality. The secondary domain controller will be our fault-tolerant domain controller, therefore set up with an example, the DHCP for 20%. Thus, if domain controller 1 goes down, we still have domain controller 2 so that our domain can still function. While making sure that our connectivity between servers, we always made sure that we were either pinging from our fully qualified domain name or the IP address to ensure that there were no naming conflicts between our servers. Now, when we were setting up our DNS, we made sure that we had a primary zone on each of our domains for that domain. And to ensure that each domain could talk to one another, we instituted stub zones to each domain, so that way we had every server and every domain's names in the server that we were sitting at. We made sure that we could replicate between the DNS domains by integrating our DNS into an Active Directory integrated system, so that whenever an update was done to the primary DNS server, it would replicate over to our stub zones. Now, I talked about earlier the DHCP scheme, and here to go further into that is my colleague Boyd Harry.
Thank you, Aaron. Good morning, AFP. We have recommended and designed a 10.x.0.0 IP address scheming, and it's a Class A, but we're forcing it as a Class B, which will give you a subnet mask of 255.255.0.0. It'll give you 256 available networks and over 65,500 nodes and hosts per network. We designed it this way because as a company that is as successful and aggressive and expanding as AFP is, it gives you plenty of room for growth as the company grows into Canada, Mexico, Africa, Asia, Australia. And we've also designed it in this way that there will be uniform IP schemes within each network. So your IT professionals should easily be able to look at an IP address, know exactly which network it is in, and what kind of hardware it is inside that network. Our starting IP scheme has us.afp with a 10.10.0.0. East us.afp is 10.20.0.0. West.us.afp is 10.30.0.0. Europe, EU.AFP is 10.40.0.0. East Europe, or East.AU.AFP is 10.50.0.0. West Europe, or West.EU.AFP is 10.60.0.0. And we space them out that way, so if you needed to add any other networks associated with, say, the US.AFP network, you still have the networks 11 through 19 available, and it gives it kind of a similar IP numbering scheme for there. Again, here is another the diagram of our network again, and as you can see, the 10.10's at the top. East US is 10.20, West US is 10.30, Europe 10.40, East Europe 10.50, and West Europe 10.60. Inside each network, we have designed an IP scheme for uniformity. These servers will be in the 10.x.0.1 through 10.x.0.20 range. These will be excluded, and as the servers are added inside that, their reservations will be made for each specific server. The print devices will have the .21 through .100 range. Wireless access points will have the .101 to .120 range. Key network elements in future expansion have .121 to .254 available. Now for your workstations, the worker bees, we have set aside 1.0 through 5.255. There's plenty of available addresses in there. The primary DHCP will be handing out 80% of the available IP addresses, and those will reside in the 1.0 through the 4.255 range. Those will be excluded on the secondary DHCP server, which will be handing out the remaining 20% in the 5.0 through the 5.255 range. And on the secondary, the first 80% will be excluded. And then for future use in expansion, you still have the 6.0 through the 255.254 available. Here's a diagram of the Europe.AFP domain in a little more detail. You can see at the top, you have your servers in the 10.40.0.1 through 10.40.0.4. At the bottom, you have your workstations and your laptops, which are in the 1.1 through the 5.255 range. And the wireless access point is the 10.40.0.101 address range. And if this will cooperate with me, we will move on to routing and remote access with my coworker, Candy Richard.
I would like to first talk today about remote routing, remote routing access service, or RAS. In our testing environment, we implemented the use of software routers using RAS servers. We deployed both LAN and demand dial interfaces, allowing routing of all LAN connections and providing remote clients access to network resources using a VPN. We recommend RAS with the RIP version 2 protocol so that routing will be more secure and efficient. RIP version 2 can be configured to send routing announcements in unicast mode. This is an advantage because it cuts down on the amount of network traffic. RAS servers can also support the use of network address translation, or NAT. We recommend configuring NAT for security purposes to protect your internal network from outside malicious attacks. NAT will allow users to make internet queries using a public IP address, thus not exposing your private IP addressing scheme.